Hello, good morning to all. I am Devakrishna Anilkumar, and today I am going to take a presentation for my project Automatic Generation of Japanese Verb Forms Dodoitsu. First, I will give a briefing about my project just like last time. Dodoitsu is a traditional form of Japanese poetry that originated in the Edo period, that is 17th to 18th and 19th century. It consists of 4 lines with a syllable pattern of 7 7 7 5. Each line contains 7 syllables except for the final line, which is 5. My project is the automatic generation of this Dodoitsu verse form. The Dodoitsu poem generator is a computational system designed to generate poems that strictly adhere to this Dodoitsu format. It uses a curated word pool segmented into topics like love, nature, work, etc., each further categorized by nouns, verbs, adjectives, and phrases. More details about the program will be explained later when I run the code. My initial proposal was to use a machine learning model to create the program, but the plan wouldn't keep up with the changes as it became too complicated. The training of large datasets and social and ethical problems was a bit troublesome, and even after all that, the poem generator is not satisfactory. Hence, I went back and started analyzing from the start. And after digging a lot, I found about dictionaries and how I could use them. So then I started another general direction in which we can generate Dodoitsu poetry without using machine learning models. Next, let's move on to aims and objectives. But first, we should recollect what I used to consider as my aims and objectives. Here, as you can see, we have the 5 different aims and objectives, that is to create a model, strictly preserve the essence of Dodoitsu, improve syllable counting accuracy, create meaningful and deep verses, and finally an attractive way. These were the old ones, and we move on to the next set of aims and objectives. And as you can see from the slides, these are essentially the same thing but in different words. In aims, you can see just like previous one, development of a Dodoitsu poem generator is to create an automated system capable of generating Dodoitsu. Cultural integration is to integrate a slice of Japanese poetry tradition into a modern computational platform, making it more accessible and interactive. Personalized content creation is to enable users to generate content based on specific themes or topics, offering a personalized experience. Next is the objectives. First one, syllable count adherence. This is to ensure that each line of the poem adheres strictly to the Dodoitsu format, that is 7775 syllable structure. Next is versatility across topics. It is to create a system flexible enough to generate poems across a variety of themes or topics such as love, nature, work, etc. Then comes semantic coherence. Beyond just syllable count, ensure that generated lines are semantically meaningful and coherent within the context of the chosen topic. Next is the expandability, which has to design the system in such a way that it can easily be expanded with more themes, words, and phrases in the future. Optimized word selection. Implement a selection mechanism that prioritizes more meaningful words and phrases while also ensuring variety in the generated content. Then comes error handling and robustness. To ensure the system can handle unknown or unexpected inputs gracefully and always produce an output even if certain word pools are depleted. Then finally, user-friendly interface. To create an intuitive and user-friendly interface for users to easily select topics to generate poems. These are our aims and objectives, which is mostly similar to what we had before. Next, let's move on to methodology. As earlier, we will first just go through the initially planned one: data collection, model development, syllable counting, refinement, creative output enhancement, evaluation, and user interface. Now let's see the currently used methodology. First of all is requirement analysis. It means to understand the primary goal of the project, that is to create an automated system for generating Dodoitsu poems. Grasping the unique 7775 syllable format is crucial since it's the backbone of Dodoitsu poems. And recognize the value of topic-based generation helps in tailoring the system to produce thematic poems. Next comes the initial system design. This phase involves laying down the foundational design elements for the poem generator. Its activities are syllable counting, a function to count syllables, ensure that generated lines always fit the Dodoitsu structure. Then word pool creation. Assemble an initial collection of words and phrases categorized by topics and types, laying the groundwork for poem generation. And then basic generation, which is to implement a primary mechanism to generate poems using the established word pool. Next comes iteration and refinement. This stage is focused on refining the system based on tests and feedbacks. It includes testing where the initial design is tested to spot potential weakness or areas for enhancement. Algorithm refinement, where the core poem generation algorithm is honed to improve its output. And then feedback loops, where adjustments are made to word selection and other parameters to continually refine the poem quality. Next was the expansion of content. This phase was to ensure rich and diverse poems, so the content base or word pool was expanded. Two steps were there here, that is word pool augmentation and new topics. More words and phrases were added to each topic, enriching the content base. Introducing additional themes increases the system's versatility, allowing for a wide range of poems. Next was optimization, which had to be put in between because the code previously exhausted word pool and it were repeatedly inputting and if we repeatedly input a single topic, it ran out of poems. To tackle that, we optimized the code by adding line generation algorithms and handling depletion mechanisms were implemented to ensure that even if a word pool is exhausted, the system can still produce output. Next comes error handling and robustness. This phase was to ensure that the system is resilient and can handle a variety of scenarios without breaking. This includes handling unknown topics so that the system should be able to respond if a user enters a topic not in the dictionary, and fallback mechanisms where the system should have backup strategies to still generate poems even if a word pool is used up. Next comes final testing and validation. Before concluding the project, the system underwent extensive testing to validate its capabilities. The system was tested across multiple topics to ensure consistency and quality. It is crucial to ensure that the poems not only fit the Dodoitsu structure but also make thematic sense. And finally, we have code refinement. This phase is to ensure that the code base is clean, maintainable, and ready for any further modifications. The code was reconstructed to improve readability and simplicity. Any redundant code segments were removed or optimized. This here shows the view of entire development process from inception to completion, ensuring the poem generator is built with precision, efficiency, and clarity. Let's look at our code. We are asked to enter a top. Before that, I will explain the code. First, starting from dependencies and libraries. The code starts by importing the random module, which is used for random selection of words and phrases, and the copy module, which helps create a deep copy of the word pool to avoid modifying the original dictionary. Word pool. Topic words is a dictionary that acts as the primary word pool. Each key represents a topic like love or nature, and its associated value is another dictionary. This inner dictionary categorizes words by their type, noun, verbs, adjectives, and phrases. Then comes syllable counting. The count syllables function calculates the number of syllables in a given word using specific rules. For example, an ending E often doesn't count as a syllable, while LE at the end of a word can count as one if preceded by a consonant. Generating a line of poetry. The generate line function at the heart of this code. Given a topic and a syllable count, it randomly selects words from the word pool, ensure that the line adheres to the specified syllable count, uses a shuffled order of word categories to add variety of generated lines, and then attempts to fill the line as much as possible. But if it can create a full line, it calls itself recursively. Then generating a Dodoitsu. The generate Dodoitsu function orchestrates the generation of complete Dodoitsu poem. It checks if the provided topic exists in the word pool, calls the generate line function 4 times to produce the 4 lines of the poem, adhering to 7775 syllable structure, then returns the completed poem. Now let's try the code and see how it works. We are asked to enter a topic here. For now, let's start with love. The generated Dodoitsu might not always be accurate. The syllables will be correct, but the meaning could be a bit grumpy. We can see the results now. Let's try love a few more times. As you can see, it's different each time. Now let's try work. Now let's try something that's not on the dictionary. Hope. It's showing unknown topic. We can see that basically the code is working well, and only sometimes it comes with non so meaningful sentences. And I think the code is basically understood by now. So let's move on to the next slide. Results. Just like what we saw just now, the code is working well and is giving fine results. Compared to how I proposed at the beginning, it is now entirely different. Compared to that, this one is really easy and less complicated. The potential of both types are endless, but still machine learning model will still be above this one as for so large collections of data and datasets. The small Dodoitsu shown here on the right side was randomly generated while I was testing, and it was really good. So that's why I included it in this slide. Next comes evaluation part. First of all, we can compare the previously proposed model. Here's the final result for that were not that satisfying. We can analyze what are the pros and what areas can be improved. So pros will be: first one, syllable adherence. The code effectively generates poems that adhere to the Dodoitsu syllable pattern of 7775 pattern. The count syllables function uses a series of rules to estimate syllable counts, which is crucial for maintaining that traditional structure. Second one, topic-based generation. The topic words dictionary allows for poems to be generated based on specific themes. This adds versatility to the code, enabling the creation of poems across a variety of subjects. Dynamic word selection. The use of random module ensures that poems are not static or repetitive. Each time a poem is generated, there is a likelihood of it being unique. Flexibility. The design is modular. Functions like generate line can be used independently, allowing for easy expansion or modification in the future. Then error handling. The code has mechanism to deal with unexpected inputs like an unknown topic, ensuring that the system doesn't break easily. As for areas of improvement, first one will be syllable counting accuracy. While the count syllables function does a decent job, it might not always be accurate for all words, especially complex ones or those from other languages. Semantic coherence. The poems generated might not always be semantically coherent. The randomness ensures variability but can sometimes lead to lines that doesn't make logical sense together, just like when we ran the code. The third one will be word pool limitations. The quality and variety of poems are directly tied to the word pool. Expanding the word pool or integrating external dictionaries or APIs would enhance the richness and diversity of generated poems. But again, it makes the code really complicated. Customizability. Future versions could allow users to add their own words or phrases to the word pool, making the tool more personalized. This is a good idea. And also, if we are able to connect it to any cloud or service like that, all of the users can input their own words, phrases and all, and make it a bigger library. Then comes UI. Finally, a UI other than the code interface is to be readied. The web-based UI or scripting will work better for this code. The reason for switching from the previous model to this code is that the code became too complicated and prone to errors when some results came and it was still not satisfactory at all. In this case, there is no need for huge data sets and training. We use our own dictionary, and compared to the machine learning model where any topic can be inputted, here we can only select from the topics list. That's just one of the small disadvantages, but still fine. For the evaluation, I think and this is it, and I think I'm concluding my project with this. Thank you.